Assalamualaikum. Today, I, Iskandar, and my friends Ihsan and Noor Azim from group EE2423F are going to present our Lab 2 report for microprocessor system ECE521, which the title is Input and Output Programming Using Assembly Language. And the objective is 1. It is able to apply program STM3 to F446RE microcontroller using assembly language, and the second objective is able to apply suitable STM32 to FX446RE instruction that can operate the input and output programming. Thank you.
For part 1 lab 2, the question asks to blink LED D1, D2 and D3. So first of all, for the coding, we need to enable GPIO clock, and we use RCC AHB1ENR, and the address is 0 times 400233830. We use port A, which are PA5, PA6 and PA7, so the GPIOA will be #1. Next, we use GPIOA model as output, and the address is 0 times 400200000. In this coding, we need to declare two types, which is BIC table and ORR table. So for the BIC table, at model 7, model 6 and model 5, it will be 0 times 000 FC00. And for the ORR table at model 7, model 6 and model 5, it will be 0 times 0005400. For BIC table, we use logit 1 both model, and because it is used to clear the pin mode. And for ORR table, we use logit 0 and logit 1 for the model, because we need to set the pin to output mode. So next, we declare GPIOA ODR for the condition, which is the address is 0 times 400200014. So for the first condition, when LED on, since it is logit low, it will be 0 times 0000 FFEF. Since it turned on, the logit 0 will be in upper side and logit 1 will be in lower side, and the ODR5, ODR6 and ODR7 will be get logit 1 and give ODR4 logit 0. So when the condition LED off and logit low, since it turned off, the logit 0 will be in upper side and lower side, but give ODR4 logit 1. So this is the coding for blinking LED D1, D2 and D3. Okay, so this is the result of question 1, part 1. So for the question 2, part 1, it is the question asks to blink LED D1, D2, D3 and D4 one by one. So first of all, we need to declare the as usual, we need to enable GPIO clock using RCC AHB1ENR, and the address is 0 times 400233830. So in this part, we use two port, which is port A, which are PA5, PA6 and PA7. So the GPIO will be hashtag GPIOA will be #1. And we also use port B, which is PB6. So the GPIOB will be #2. So next, we also use GPIOA model, which is the address is 0 times 400200000, and also use the same table, which are BIC table and ORR table. At model 6, model 7 model 5. So, and we also use GPIOB model, and the address is 0 times 40020 and the BIC table at model 6, and it will be 0 times 0000 3000, and ORR table at model 6, it will be 0 times 0000 1000. So next is the condition of LED. So first of all, we need to declare the GPIOA BSRR that I use in this part. So the address is 0 times 400200018. For the first condition, to turn on the active low is when LED PA5, PA6, PA7 at condition GPIOA turn on, but GPIOB turn off is 0 times FFFF. So next, when LED PA5 turn on is 0 times FFFF FFDF. When LED PA6 turn on, it will be 0 times FFFF FFBF. And lastly, when LED PA7 turn on, it will be 0 times FFFF FF7F. So next is we also use GPIOB BSRR, which is the address is 0 times 40020 It is the same as the GPIOA BSRR. When LED PB6 at condition GPIOB turn off, it will be GPIOA turn on is 0 times FFFF FFFF. So when LED PB6 at condition GPIOB turn on, will be GPIOA turn off is FFFF FFBF. So this is the coding. So this is the result. Okay, so for the part 2 in lab 2, there are 3 condition and using switch, which is for the first one is when the S1 being pressed, LED D1, D2 and D3 will blink. When the S2 being pressed, LED D1 until D4 turns on one by one. When no push button being pressed, all LEDs off. So it is the continue with the part 1 uh, part 1A and B. So we just need add some coding, and the addition will be GPIOA model for input 0 times 4002000. We only use BIC table at model 1 and model 2, and it will be 0 times FFFF FFC3. The reason why we use only BIC table is that to set the pin to input mode. We also use GPIOA IDR, which is the address 0 times 4002010, and we also use masking, which is 0 times FFFF FFEC at IDR4, IDR1, and IDR0. The switch button that connected to IDR4, IDR1, IDR0 will be 0, and the others will be logic 1 because it is in condition, the switch in condition logic low, which is the um, switch is at the ground. And when the PB1 and PB2 free, it will be give 0 times FFFF FFFF. Okay, we also use the for the condition, we also use GPIOA BSRR, which is the address is 0 times 4002018. So when PB1 on and PB2 off, the LED1, LED2, and LED3 will be turned on, which are 0 times FFBF, FFFF, means that at upper side will be logic 1 to turn on the LED. When PB2 on and PB1 off, the LED1, LED2, LED3 are turned on, which are 0 times FFFF, FF1F, means that at lower side will be logic 0, turn on LED. So this is the full coding. We just need to add switch coding and masking before the coding of the condition when blinking LED and also blinking LED one by one. So we use NR0 R0 R1, means that R0 is equal to R1 and will be loaded into R0, which is to enable all the push button by using masking so that the program will read from the input device. We also use CMP R0 R2 to compare between R0 and R2, where R0 is the condition whether the PB1 push or PB2 push, and R2 is when all the button is free. Okay, when condition is false, branch if equal L1 will function that used to jump to specified address, which is to loop, which is will go to loop L1, so it will execute the condition PB1 is push, which is 0 times FFBF FFFF. So when condition is true, where PB2 push, it will execute the condition without jump to L1, but the program will not end because there is delay loop in each coding. It will continuously looping and called as infinite loop since there is delay loop. So the difference between delay and delay one here is that the delay is used in overall program, while for delay one is used only for condition when PB1 is pushed. So this is the result for part 2 lab 2, which is for the first one is to when the PB1 is pressed, it will bring LED D1, D2, and D3. For the second condition, PB2 is pressed, it will bring LED D1, D2, D3, and D4 one by one. And when no button press, the LED will be turned off.
Okay, for part 1, question 1. First we start, then initialization port, setup function, and then LED 1, 2, and 3 will be on. Then it will delay for 0.5 seconds, and LED 1, 2, and 3 will be off, and delay again for 0.5 seconds, and it will loop forever. Part 1, question number 3. We start an initialization port, setup function, then LED 1 will be on, delay for 0.5 seconds, and then LED 2 will be on, delay for 0.5 seconds, then LED 3 on, delay 0.5 seconds, and LED 4 on, delay for 0.5 seconds, and it will loop forever. Okay, for part 2, Start initialization port setup function. First, scanning switch 1. If on, it will go to LED 1 will be on and delay. If no, it's scanning switch 2. If switch 2 on, it will on LED 2 and delay. If no, it's scanning switch 3. If switch 3 are on, it will on LED 3 and delay. If no, it will go to this process again. And conclusion. We learn how to use a microprocessor in real-life usage, especially STM32F446RE ARM Cortex-M4 processor. We learn to use coding that we have studied to finish this project where first part, we must do a coding for 3 LED that connect to ARM to blinking at the same time. We learn to use I/O port to finish this project like RCC, AHB1, ENR, GPIOB, model, and GPIOB ODR. We also can determine the right coding for each component for connection with this microprocessor. For part 2, it has slightly more coding to use as we have add more component that is button. The button acts as switch to turn on LED as required for our lab demand. We have used almost same I/O ports for this work like the first one we have used. As conclusion, we have achieved our objective for this lab.